Number 3. A particle P of mass 4 kilograms is at rest at the point A on a smooth horizontal plane. At time t is equal to 0, two forces F1, which is equal to 4I minus j newtons, and F2, lambda I plus mu j newtons, where lambda and mu are constants, are applied to P. Given that P moves in the direction of the vector 3I plus j, show that lambda minus 3 mu plus 7 is equal to 0. So we know that there are two forces that are being applied to particle P, which is F1 and F2. This means that particle P will have a resultant force, and in order to find this resultant force, we would have to add F1 and F2. So F1 is 4I minus j, and F2 is lambda I plus mu j. If we now add the I vectors to each other, we will have 4 plus lambda I, and the j vectors would be mu minus 1 j. Because we're told that P moves in the direction of vector 3I plus j, this means that the resultant force is therefore going to be a multiple of this vector. We can therefore write the multiple as k and then put our 3I plus j, and this should be equal to the resultant force that we found earlier. If we expand this with the k constant, we will have 3ki plus kj is equal to the resultant force that we found. If we now equate the I coefficients, we will have 3k is equal to 4 plus lambda, and if we equate the j coefficients, we will have k is equal to mu minus 1. In order to eliminate the k so that we can just work with lambda and mu, we can multiply this second equation by 3, which will make it 3k is equal to 3 mu minus 3. So if 3k is equal to 4 plus lambda, and 3k is also equal to 3 mu minus 3, we can therefore equate both of these to say 4 plus lambda is equal to 3 mu minus 3. If we then move everything onto the left-hand side, we will have 4 plus 3 plus lambda minus 3 mu is equal to 0. And to put it in the form that they have asked for in the question, we will first put the lambda minus 3 mu, and we can simplify the 4 plus 3 to give us plus 7, and this is equal to 0, as was required for part A. Part B says, at time t is equal to 4 seconds, P passes through the point B. Given that lambda is equal to 2, find the length AB. So because we now know what lambda is, we can substitute lambda in order to find mu. So when lambda is equal to 2, we can substitute it and say 2 minus 3 mu plus 7 is equal to 0. And to make mu the subject, if we do 2 plus 7, that first gives us 9 minus 3 mu is equal to 0, which means that 9 is equal to 3 mu, and therefore mu is equal to 3. We can therefore now find our resultant force by substituting these in. So 4 plus our lambda, which is 2, is the I vector, and mu, which is 3 minus 1, will give us the j vector. And this will therefore give us 6i plus 2j. Because this particle is moving, we therefore can now use the equation force is equal to mass times acceleration, and the mass has been given to us as 4 kilograms. So the resultant force, which is 6i plus 2j, would therefore be equal to 4 times the acceleration. And in order to find the vector for acceleration, we would divide everything by 4, which would give us 1.5i plus 0.5j. The question is asking us to find the length, which means the distance of AB, and in order to do that, we would first have to find the displacement. So we can now use our SUVAT to help us find that. We know that the acceleration is 1.5i plus 0.5j, and we know that the initial velocity is 0. We know that the time is equal to 4, And displacement is what we are looking for. So in order to find that, we will use the equation S is equal to ut plus a half at squared. If we now substitute everything in, u is 0, t is 4, and we have plus a half, our a vector, and t, which is 4 squared. 0 times 4 is 0, and a half times 4 squared is a half times 16, which gives us 8. So 8 times 1.5i plus 0.5j would therefore give us 12i plus 4j. So what we now have is a vector for the displacement, and because we are looking for the distance, we are going to find the modulus of this vector. So we can find the distance by doing 12 squared plus 4 squared and then square root the answer. And if we work that out, that would give us 4 root 10 meters. And that is the final answer for the length of AB.